welcome to Milky Narratives. As the world around you grows quiet, allow your mind to slow down and your imagination to awaken. Tonight, we journey through distant galaxies, forgotten worlds, and the endless silence between the stars. 1. Before complexity existed. Imagine a universe where nothing had a name. No stars, no planets, no oceans, no life. Only a sea of simple particles drifting through unimaginable darkness. And yet everything you have ever known was already quietly waiting inside that simplicity. No stars scatter light across the darkness. No planets circle distant suns. No galaxies stretch like glowing islands across unimaginable oceans of space. There is no sky to admire, no horizon to measure, no living creature to wonder where it all began. There is only silence. Not the comforting silence of a quiet night, but a silence so complete that even the idea of sound has not yet found a place to exist. And drifting through that immense emptiness are only the simplest ingredients imaginable. Tiny particles, fleeting flashes of energy, gentle ripples spreading across space that itself has only recently begun expanding. Nothing about this scene appears remarkable. Nothing seems capable of producing oceans, forests, civilizations, music, memories, or the quiet breath you are taking at this very moment. Yet hidden within that astonishing simplicity lies every mountain ever climbed, every heartbeat ever felt, every star that will one day illuminate the night sky. Everything already exists, not as finished objects, but as possibility. Perhaps this is one of the most beautiful ideas modern cosmology has offered us. Complexity does not suddenly appear from nowhere. Instead, it unfolds patiently, almost imperceptibly, from rules that are surprisingly simple. The universe never needed to become complicated overnight. It simply allowed simple things enough time to meet one another. If we could somehow travel back more than 13 billion years, the universe would appear almost disappointingly plain. There would be no recognizable landmarks, no spiral galaxies, no glittering nebulae, no black holes swallowing light. Even the atoms that now compose your body would not yet exist. Hydrogen and helium would dominate nearly everything. The periodic table, so familiar inside classrooms today, would still be waiting to be written by the lives and deaths of stars that had not yet been born. It is strange to imagine. The iron flowing through your blood, the calcium inside your bones, the oxygen filling your lungs. Every one of those atoms depended on events that had not happened yet. The universe, at that ancient moment, possessed none of the richness we now take for granted. And yet, nothing was missing. The recipe was already complete. Only the cooking had barely begun. This gentle unfolding is one reason the cosmos feels so different from the stories humans often tell. In myths, worlds appear through dramatic acts. A command is spoken. A giant awakens. A creator shapes mountains from clay. Creation happens quickly. The scientific story is quieter, far quieter. It is the story of extraordinary patience. Tiny fluctuations become larger over millions of years. Clouds slowly gather under gravity's persistent pull. Stars ignite one by one. Inside their brilliant cores, entirely new elements begin to form. When those stars eventually reach the ends of their lives, they scatter those newly forged ingredients back into space. Nothing is wasted. Nothing appears rushed. Every ending quietly prepares another beginning. If you were somehow able to speed up billions of years into only a few minutes, the universe might resemble an enormous garden, not one planted all at once, but one where seeds bloom at different times. Some flowers appear early, others wait patiently beneath the soil. Entire forests emerge from what once looked like empty ground. From a distance, the growth appears effortless, but each leaf depends upon countless invisible processes unfolding beneath the surface. Perhaps the universe grows in much the same way. Complexity is not added from outside. It grows naturally from relationships already hidden inside simplicity. That idea reaches far beyond astronomy. Snowflakes emerge from simple water molecules. Crystal structures form from repeating atomic arrangements. Coastlines develop through countless ordinary waves meeting solid rock. Even life itself may have begun through unimaginably long sequences of ordinary chemical reactions, each one small enough to seem almost insignificant. Nature rarely builds through miracles. Instead, it builds through repetition. Small changes accumulate. Patterns reinforce one another. Order slowly emerges from countless simple interactions. There is something deeply calming about this realization. It reminds us that enormous transformations rarely require enormous beginnings. Sometimes they require only time. Enough time for simple rules to reveal everything they have been quietly capable of accomplishing all along. The earliest universe was astonishingly uniform. Almost everywhere looked remarkably similar. Yet hidden inside that near-perfect smoothness were incredibly tiny differences. Minute variations in density, small fluctuations in temperature. Differences so slight they would have been almost impossible to notice directly. And yet, those tiny irregularities changed everything. Gravity favored the slightly denser regions. Matter drifted gently toward matter. The denser places became denser still. Over millions and then billions of years, these barely noticeable imbalances became immense cosmic structures. Galaxies formed, clusters assembled, filaments stretched across unimaginable distances. The magnificent architecture we observe today may owe its existence to differences so small they once seemed almost meaningless. There is a quiet lesson hidden within that thought. Sometimes the smallest variations become the foundations of the greatest structures. The universe did not require perfection. It required just enough imperfection for creation to begin. Without those tiny irregularities, stars may never have formed. Without stars, heavier elements would never have existed. Without those elements, planets would remain impossible. Without planets, oceans, chemistry, and life might never have appeared. Everything depended upon gentle asymmetry. A universe that was almost perfectly balanced, but not quite. Perhaps beauty often begins exactly there. Not in flawless order, but in delicate imbalance. As the first generations of stars slowly illuminated the darkness, complexity accelerated. Each new star became both a source of light and a factory of possibility. Inside their blazing interiors, matter discovered entirely new ways to organize itself. Hydrogen became helium. Helium became carbon. Carbon eventually helped give rise to chemistry rich enough for living systems. One transformation quietly opened the door to another. The universe did not leap toward complexity. It climbed patiently, one invisible step after another. And perhaps that is why our own existence feels connected to something unimaginably ancient. Every atom within us carries a history far older than Earth itself. Every breath continues a story that began long before there were planets capable of breathing. When we look at ourselves, we are not separate from the early universe. We are one of its latest conversations. The remarkable simplicity that once filled all of existence has never truly disappeared. It has merely learned over billions of years how to tell increasingly beautiful stories. 2. When simple things learn to build. Before there were forests, before there were oceans, before there were even stars capable of warming a single planet, the universe possessed only an astonishingly small collection of ingredients. It almost seems impossible. Everything we know today, every galaxy stretching across millions of light years, every mountain rising above an ocean, every living cell quietly carrying out its invisible work, can be traced back to a handful of remarkably simple building blocks. No architect stood outside the universe arranging these pieces by hand. No hidden craftsman assembled galaxies like towers built from cosmic bricks. Instead, the particles themselves followed a few elegant rules with extraordinary patience. Perhaps that is the greatest miracle of all. Not that complexity exists, but that simplicity, given enough time, naturally learned how to create it. If we could shrink ourselves smaller than atoms and watch the earliest moments of cosmic history unfold, we would not witness organized worlds. We would see motion, endless motion, particles colliding, separating, meeting again, energy transforming into matter, matter transforming back into energy, all governed by laws that seem almost breathtakingly simple. Nothing in those tiny interactions appears capable of producing consciousness. Nothing hints at music, language, art, or dreams. Yet every one of those possibilities already rests quietly inside the rules themselves. It is rather like listening to the first few notes of an unfamiliar symphony. The opening sounds may seem almost ordinary. Only much later do we realize they contained the beginning of an extraordinary masterpiece. Nature rarely announces its greatest achievements at the moment they begin. Instead, it whispers. One of the remarkable characteristics of the universe is that large structures rarely appear all at once. They emerge gradually through cooperation. Atoms join together into molecules. Molecules combine into more elaborate chemical structures. Clouds of gas collapse into stars. Stars gather into galaxies. Galaxies collect into enormous clusters connected by invisible filaments stretching across the observable universe. At every level, larger patterns arise because smaller pieces interact according to remarkably consistent laws. The universe seems almost reluctant to skip steps. Each new layer depends upon the quiet success of countless smaller ones beneath it. Imagine watching a single snowflake form. No individual water molecule understands the beautiful crystal it is helping create. Each molecule simply responds to its immediate surroundings: temperature, pressure, nearby neighbors. Yet, together they produce patterns so intricate that no two snowflakes appear exactly alike. Perhaps galaxies emerge in much the same fashion. No hydrogen atom knows it is helping build a spiral galaxy. No grain of interstellar dust understands that one day it may become part of a planet. Each particle simply follows local rules. The breathtaking order appears only when billions upon billions of these tiny decisions accumulate across unimaginable stretches of time. This principle appears again and again throughout nature. Birds flying together form graceful flocks without any single bird directing the entire movement. Ant colonies construct elaborate underground cities, although no individual ant possesses a blueprint for the whole design. Even your own brain operates through billions of individual neurons, none of which understands the complete experience we call consciousness. Complexity often emerges not because individual pieces become more intelligent, but because relationships between them become richer. Perhaps the universe itself is the greatest example of emergence ever known. Simple things never truly learned in the human sense. They simply continued interacting. And over billions of years, those interactions revealed possibilities hidden inside reality from the very beginning. Gravity became one of the universe's most patient builders. Unlike explosions that demand attention in an instant, gravity works quietly. It never grows tired. It never becomes distracted. It simply continues pulling. A tiny cloud of gas becomes slightly denser. That greater density strengthens gravity. Stronger gravity attracts even more gas. The process feeds itself slowly until, after millions of years, immense clouds collapse into newborn stars. Nothing dramatic needs to happen in a single moment. Time performs much of the work. This extraordinary patience is one reason the cosmos feels almost alive, even though its processes obey physical laws rather than conscious intention. Everything grows gradually. Everything builds upon what came before. The universe seems less like a machine assembling fixed components and more like an endless conversation where each generation of structures gives rise to entirely new possibilities. Stars themselves became remarkable teachers of complexity. Inside their blazing cores, temperatures climbed high enough for atomic nuclei to fuse together. Hydrogen became helium. Helium eventually helped produce carbon, oxygen, silicon, iron, and dozens of other elements. Each new element expanded the vocabulary available to nature. Before stars existed, chemistry could speak only in short, simple sentences. After generations of stellar evolution, entirely new stories became possible. Rocky planets could form, liquid water could gather, organic molecules could assemble into astonishing arrangements. Life itself may simply represent chemistry continuing its conversation with increasing sophistication. The remarkable thing is that none of these later achievements required new physical laws. The same gravity, the same electromagnetism, the same nuclear forces, the same quantum behavior. Everything that shapes your daily experience also governed the first moments after the universe began. The rules never became more complicated, only the patterns built from those rules continued growing richer. That realization carries a quiet elegance. Sometimes we imagine progress requires replacing old foundations with entirely new ones. Nature often does the opposite. It keeps the foundations unchanged while allowing endless combinations to emerge above them. The alphabet contains only a few dozen letters, yet those letters produce libraries filled with countless stories. Music relies upon a limited collection of notes, yet symphonies remain infinite in their emotional variety. Perhaps the universe works in much the same way. Its fundamental laws resemble a small alphabet from which every galaxy, every planet, every living organism, and every wondering mind has gradually been written. As complexity increased, entirely new behaviors appeared that could never have been predicted simply by examining isolated particles alone. Life began storing information. Evolution began refining successful patterns. Brains began modeling the world around them. Eventually, somewhere on one ordinary planet, orbiting one ordinary star, the universe developed beings capable of asking how all this complexity arose. There is something wonderfully circular about that idea. The particles born in the early universe eventually organized themselves into minds capable of contemplating their own origins. Hydrogen became stars. Stars forged carbon. Carbon became cells. Cells became living creatures. Living creatures became observers. And observers learned to look back across billions of years, tracing every astonishing layer of complexity toward those first simple beginnings. Perhaps that is the quiet beauty hidden inside the entire cosmic story. The universe never abandoned simplicity. It simply discovered, one patient step at a time, how infinitely creative simplicity could become. 3. The universe's first great architects. Long before oceans shimmered beneath distant suns, before galaxies stretched their graceful arms across billions of light years, and before the first atom ever dreamed of becoming part of a living cell, two quiet forces had already begun shaping everything that would ever exist. Gravity and time. Neither could be touched. Neither could be held in your hands. Yet together they would become the oldest architects in the universe. Perhaps that is one of the deepest ideas modern science has revealed. The cosmos did not need intention, blueprints, or careful planning. It simply followed a handful of remarkably simple laws with extraordinary patience. Given enough time, those laws transformed almost featureless simplicity into unimaginable complexity. If we could somehow travel backward to the universe's earliest moments after its rapid expansion, we would not recognize anything familiar. There were no stars suspended against velvet darkness, no galaxies glowing quietly in the distance, no planets circling warm suns. Instead, the universe was astonishingly uniform. Matter filled space almost evenly in every direction, interrupted only by incredibly tiny variations in density. These differences were almost impossible to notice. In many places, one region contained just a tiny fraction more matter than another. The imbalance was so slight that it amounted to only about 1 part in 100,000. To human eyes, such differences would seem meaningless. To gravity, they changed everything. Gravity possesses an extraordinary quality that few other forces share so completely. Every small advantage grows stronger with time. A region containing slightly more matter exerts slightly more gravitational pull. That stronger pull attracts additional matter, making the region heavier still. As it grows denser, its gravity becomes stronger yet again, drawing in even more surrounding material. The process feeds itself naturally. No instructions are required. No guiding intelligence needs to intervene. The universe simply allows gravity to keep working. What begins as the faintest imbalance slowly transforms into something entirely new. Imagine placing a single drop of rain onto a smooth hillside. At first, it barely moves. Yet, as more droplets join it, the tiny trickle becomes a stream. Streams merge into rivers. Rivers reshape entire landscapes. Gravity behaves in much the same quiet fashion. Tiny differences become enormous structures simply because enough time is allowed to pass. This remarkable process unfolded over hundreds of millions of years. Invisible clouds of hydrogen and helium slowly drifted together. At first, their motion was almost imperceptible, but with every passing age, gravity continued its patient work. The clouds became denser, temperatures gradually rose, pressure increased deep inside collapsing regions until one extraordinary threshold was finally crossed. Nuclear fusion ignited. The first stars were born. It is tempting to imagine these first stars appearing dramatically, like fireworks exploding across a dark sky. The reality was likely far quieter. One by one, scattered across an expanding universe, small islands of light slowly awakened after an unimaginably long darkness. Each newborn star became far more than a source of light. Inside their brilliant cores, entirely new forms of matter began to appear. The early universe contained mostly hydrogen and helium, the simplest elements imaginable. But stars became cosmic furnaces capable of forging carbon, oxygen, silicon, magnesium, calcium, iron, and dozens of other elements through nuclear fusion. Everything familiar to us today depended upon this quiet transformation. The calcium inside your bones, the oxygen you breathe, the iron flowing through your blood, the carbon that forms every living cell. None of these elements existed in meaningful abundance during the universe's earliest moments. Stars became the first great factories of complexity. Yet even they were not the final architects. As massive stars exhausted their fuel, many ended their lives in astonishing explosions known as supernova. For a brief moment, these dying stars outshone entire galaxies, scattering newly created elements across enormous distances. What appears violent from one perspective becomes profoundly creative from another. Death became distribution, explosion became construction. The ashes of ancient stars drifted outward, enriching enormous clouds of gas that would someday collapse again into entirely new generations of stars. Around many of these younger stars, disks of dust and gas slowly formed. Within those disks, gravity resumed its patient work once more. Tiny grains of dust collided gently. Some bounced apart. Others clung together through electrical forces. Millimeter-sized particles gradually became pebbles. Pebbles became rocks. Rocks merged into mountain-sized bodies. Eventually, entire planets emerged from countless quiet collisions occurring over tens of millions of years. Nothing happened quickly. The universe rarely hurries. Its greatest achievements are usually measured not in minutes or centuries, but in millions and billions of years. From our human perspective, such timescales feel almost impossible to comprehend. Yet perhaps patience itself is one of the defining characteristics of cosmic creation. Gravity never grows impatient. Time never becomes distracted. Together they continue building, long after individual stars fade away. Modern astronomy has revealed something equally beautiful about this process. The vast web of galaxies stretching across the observable universe resembles an intricate network of glowing filaments, separated by enormous cosmic voids. Computer simulations suggest that this magnificent structure naturally emerged from gravity, acting upon tiny density variations left behind in the early universe. The largest structures ever discovered may therefore owe their existence to differences so small they would once have seemed insignificant. There is something quietly reassuring in that thought. Great complexity does not always require dramatic beginnings. Sometimes the smallest imperfections become the seeds of astonishing beauty. Nature seems remarkably comfortable, allowing immense order to emerge from subtle asymmetry. This lesson appears again and again throughout the cosmos. Stars emerge from slight imbalances. Galaxies arise from gentle accumulations. Planets form through countless tiny collisions. Even life itself, as far as we understand, may have begun through countless small chemical interactions repeated over immense spans of time. The universe does not leap toward complexity. It drifts there, almost imperceptibly, almost peacefully. Looking upward into the night sky, it is easy to admire the finished masterpieces, the glowing galaxies, sparkling star clusters, and colorful nebulae that fill astronomical photographs. Yet, those magnificent sights are only the visible chapters of a much longer story. Behind every brilliant galaxy lies billions of years of quiet construction. Behind every star lies an invisible history of collapsing clouds. Behind every planet lies an almost unimaginable sequence of tiny events patiently woven together by gravity and time. Perhaps that is why the universe feels so deeply calming. Its greatest creations were never rushed. They were allowed to become exactly what the laws of nature patiently shaped them into, one gentle step after another. And somewhere within that endless architecture, on one small planet orbiting one ordinary star, gravity and time eventually built something capable of looking back toward the heavens, wondering how the oldest architects of reality quietly constructed everything we have ever known. 4. Why order emerges from chaos. The universe rarely introduces itself as orderly. When we look into the night sky, we often see explosions, collisions, violent radiation, and immense clouds twisting through space. Entire stars tear themselves apart. Black holes consume anything wandering too close. Galaxies collide over hundreds of millions of years, reshaping one another in slow cosmic dances that appear almost unimaginably chaotic. At first glance, the cosmos seems governed by disorder. And yet somehow, every act of apparent destruction becomes the beginning of something new. This remarkable tendency raises one of the most beautiful questions in all of science. Why does order keep emerging from chaos? Perhaps the answer begins with the way we understand the word chaos itself. To human eyes, chaos often means randomness without purpose. We imagine complete confusion, where nothing meaningful can ever arise. But nature seems to define chaos differently. In many physical systems, disorder is not the opposite of structure. Instead, it becomes the raw material from which new patterns slowly emerge. The universe does not avoid chaos, it quietly transforms it. Imagine standing beside a calm river after a heavy rainstorm. At first, the water appears wild and unpredictable. Countless droplets tumble over one another in every direction. Yet, if you step back, a larger pattern becomes visible. The river still follows the shape of its valley. Small whirlpools form behind rocks. Gentle waves repeat themselves again and again. Even within turbulence, hidden order quietly reveals itself. The cosmos behaves in much the same way. Individual events may seem unpredictable, but over enormous scales, elegant patterns begin to appear. This is one of the deepest lessons modern physics continues to teach us. Simple rules repeated across immense stretches of time often produce astonishing complexity without ever abandoning their underlying simplicity. Snowflakes offer a beautiful example. Every snowflake forms from water molecules drifting through cold air. Their paths appear almost random. Tiny changes in temperature, humidity, and surrounding conditions influence each molecule differently. Yet despite these countless variations, nearly every snowflake displays extraordinary symmetry. No one designs those delicate branches. No hidden artist carves each crystal individually. The geometry simply emerges because water molecules naturally arrange themselves according to the laws governing their interactions. Order appears without instruction. Beauty arises without intention. The universe seems remarkably comfortable, allowing elegant structures to build themselves. This same principle stretches far beyond Earth's atmosphere. Inside enormous clouds of interstellar gas, turbulence creates regions of compression and expansion. At first, these clouds appear shapeless, drifting almost aimlessly through space. But gravity slowly amplifies tiny differences in density. Dense regions gather more material. New stars ignite. Around those stars, planets gradually begin to form. What once appeared to be an untidy cloud eventually becomes an organized planetary system. Once again, chaos becomes creation. Even galaxies themselves reveal this quiet transformation. When two galaxies approach one another, the event sounds catastrophic. Billions of stars begin changing their orbits. Vast clouds of gas collide. Enormous gravitational forces stretch both galaxies into distorted shapes unlike anything they previously possessed. To us, such collisions resemble destruction, yet astronomical observations tell another story. These encounters often trigger extraordinary waves of star formation. Compressed gas clouds collapse more efficiently. New generations of stars begin illuminating regions that had remained dark for millions of years. Over time, the two galaxies merge into a larger, more stable system, possessing graceful structures entirely different from either original galaxy. What looked like disorder becomes the birthplace of fresh order. Nature rarely wastes an opportunity to build. Perhaps this tendency extends even deeper than astronomy. Many of the patterns surrounding us every day arise through similar processes. Sand dunes organize themselves beneath shifting winds. Ocean waves produce repeating rhythms from countless moving water molecules. Crystals grow into astonishingly regular shapes, despite beginning with individual atoms arriving one by one. Even living organisms emerge through countless tiny chemical reactions that individually appear insignificant. Complexity grows because local interactions quietly reinforce one another. The universe seems filled with systems capable of organizing themselves. Scientists sometimes describe these as self-organizing systems. No central authority controls them. Instead, every small piece follows simple physical laws while responding only to nearby conditions. Out of these countless local interactions, larger structures gradually emerge. Birds flying together create graceful flocks without a leader directing every movement. Fish form shimmering schools that twist almost like single living creatures. Clouds produce intricate swirling patterns visible from orbit. Nature repeatedly demonstrates that remarkable organization can arise without detailed planning. Perhaps the cosmos itself is the largest self-organizing system of all. This perspective changes how we think about beauty. We often imagine beauty as something carefully designed. Nature suggests another possibility. Beauty may simply be what stable patterns look like when observed by curious minds. The elegant spiral arms of galaxies, the nearly perfect rings of Saturn, the hexagonal snowflake, the branching of rivers, the veins inside a leaf, the spiral arrangement of sunflower seeds. Again and again, similar mathematical relationships quietly appear across scales that differ by billions of times in size. The same geometry whispers through atoms, flowers, hurricanes, galaxies, and perhaps even the large-scale structure of the observable universe. It is almost as though reality possesses a quiet preference for certain forms, not because those forms are chosen deliberately, but because they naturally emerge whenever matter and energy interact over long enough periods. Time itself becomes an essential partner in this process. Without time, order has no opportunity to develop. A single instant captures only motion. Millions of years reveal patterns. Billions of years reveal architecture. The universe does not hurry toward organization. It allows countless experiments to unfold simultaneously. Most disappear almost immediately. Others prove stable enough to endure. Those enduring structures become the foundations upon which even greater complexity eventually grows. There is something deeply comforting in that realization. The cosmos does not demand perfection from the beginning. It allows mistakes. It allows turbulence. It allows immense periods of uncertainty. And from those uncertain beginnings, extraordinary stability slowly emerges. Perhaps human civilization reflects this same principle. Knowledge grows through countless failed ideas. Scientific understanding advances through corrections rather than certainty. Individual lives often become meaningful, not because every moment unfolds perfectly, but because order gradually emerges from experiences that once felt confusing. In that sense, the universe may be teaching the same lesson everywhere we choose to look. Chaos is rarely the end of the story. More often, it is simply the opening chapter. As we continue looking deeper into space with increasingly powerful telescopes, we repeatedly encounter evidence that complexity, symmetry, and beauty are not fragile exceptions hidden within an otherwise disordered universe. Instead, they appear to be natural consequences of remarkably simple laws, acting patiently across immense expanses of space and time. Perhaps that is the quiet miracle surrounding us every night. The universe has never been perfectly ordered, nor has it ever been truly chaotic. It has always existed in the beautiful space between the two, where simple rules patiently weave endless complexity from apparent disorder, allowing galaxies, stars, planets, oceans, forests, and eventually wandering minds to emerge from the same ancient dance that began billions of years ago and continues, even now, beneath the silent canopy of the stars. 5. The long journey toward life. Before there were forests swaying beneath gentle winds, before oceans shimmered under blue skies, and before a single living cell divided for the first time, the universe spent billions of years preparing a stage that no one yet existed to witness. Life, remarkable as it seems, was never the opening chapter. It was the result of an extraordinarily long story already unfolding across the cosmos. Perhaps that is what makes our own existence feel even more astonishing. Every heartbeat, every breath, every thought depends upon a chain of events stretching back almost to the beginning of time itself. Nothing appeared overnight. Everything arrived one quiet step at a time. Modern astronomy often reminds us that the universe is about 13.8 billion years old. Yet for a surprisingly long portion of that immense history, life almost certainly did not exist anywhere. The earliest universe was simply too young. The first few minutes produced only the lightest elements, mostly hydrogen and helium, with tiny amounts of lithium. These simple ingredients were enough to fill the expanding cosmos, but not enough to construct the extraordinary chemistry life would eventually require. Carbon was absent. Oxygen was absent. Nitrogen, phosphorus, sulfur, calcium, iron. Every essential ingredient that living organisms depend upon had not yet been created. The universe first needed stars. Only inside their blazing interiors could heavier elements slowly be forged through nuclear fusion. Over millions of years, stars quietly transformed hydrogen into helium, helium into carbon, carbon into oxygen, and onward toward ever more complex elements. Then, when many of those stars reached the end of their lives, they returned their newly created matter to space. Ancient supernovae scattered these precious elements across the galaxy like seeds carried upon invisible winds. Those seeds would wait patiently. Eventually, they mixed into enormous clouds of gas and dust, where entirely new generations of stars began to form. This second generation of stars differed from the first in one important way. Now they possessed richer chemistry. Around many of them, swirling disks of dust contained silicon, iron, carbon compounds, frozen water, and countless complex molecules unavailable to the earliest stars. The ingredients for rocky planets had finally arrived. Once again, gravity resumed its patient work. Tiny grains collided, small rocks merged into larger bodies. Planets gradually emerged over tens of millions of years. Some became scorching worlds where molten rock flowed freely across their surfaces. Others grew into frozen giants wrapped in thick atmospheres. A fortunate few settled into regions where temperatures allowed liquid water to remain stable. Earth became one of those rare worlds. But even then, life did not immediately appear. The young Earth looked nothing like the peaceful planet we know today. Its surface endured relentless asteroid impacts. Volcanoes erupted across enormous regions. The atmosphere contained almost no oxygen. Oceans, though already present, were chemically unlike modern seas. By human standards, it would have seemed astonishingly hostile. Yet beneath that apparent violence, something remarkable may already have been beginning. Chemistry was becoming increasingly adventurous. Simple molecules drifted through oceans, lakes, hydrothermal vents, and perhaps even shallow pools warmed by volcanic activity. Sunlight, lightning, geothermal heat, and chemical gradients supplied energy continuously. Atoms combined, separated, recombined. Countless reactions unfolded every second across the young planet. Most accomplished nothing lasting. But nature possessed one extraordinary advantage: time. When millions of years become billions, even highly improbable events receive unimaginable numbers of opportunities to occur. Every wave washing onto an ancient shoreline represented another experiment. Every volcanic vent became another laboratory. Every tiny mineral surface offered another chance for molecules to meet in entirely new arrangements. Nature did not rush, it simply kept trying. Somewhere within this endless chemical conversation, certain molecules became capable of storing information. Others became better at copying themselves. Still others formed protective membranes, creating tiny boundaries that separated one chemical environment from another. Exactly how these first steps unfolded remains one of science's greatest unanswered questions. Researchers continue exploring multiple possibilities. Perhaps life began near deep-sea hydrothermal vents, where mineral-rich water emerged from Earth's crust. Perhaps shallow tidal pools repeatedly concentrated organic molecules as water evaporated. Perhaps icy environments preserved delicate compounds long enough for greater complexity to emerge. Or perhaps several pathways operated simultaneously before one ultimately succeeded. The beautiful truth is that we simply do not know. And that uncertainty makes the story even more fascinating. For all our scientific achievements, the precise moment when chemistry quietly crossed the threshold into biology remains hidden somewhere in Earth's distant past. There was probably no dramatic announcement, no sudden flash of light, no unmistakable dividing line. Instead, life may have emerged gradually, becoming increasingly difficult to distinguish from ordinary chemistry, until one day the difference became undeniable. Matter had learned to copy itself, to consume energy, to preserve information, to evolve. The universe had entered an entirely new chapter. What followed was anything but immediate. For billions of years, Earth remained a microbial world, tiny single-celled organisms dominated the oceans, while continents slowly drifted across the planet's surface. Photosynthetic microbes gradually transformed the atmosphere by releasing oxygen, forever changing Earth's chemistry. This enormous transition required hundreds of millions of years. Again, patience defined the universe's greatest achievements. Complex cells eventually appeared. Then multicellular organisms, soft-bodied creatures, shells, fish, plants, forests, dinosaurs, mammals, primates. Finally, after nearly 4 billion years of biological evolution, one species developed the ability to wonder how life itself had begun. Looking backward across that immense history, it becomes impossible not to feel humbled. Human civilization occupies only the tiniest fraction of life's story. Written history spans merely thousands of years. Agriculture, only slightly longer. Modern science, just a few centuries. Compared with the patient rhythm of cosmic evolution, our own experience resembles a single heartbeat. Yet perhaps that brevity gives our curiosity special significance. We are the first known inhabitants of Earth, capable of reconstructing the long journey that made our existence possible. With telescopes, we now observe newborn planetary systems forming around distant stars. With chemistry, we recreate molecules that may have existed on the early Earth. With biology, we decode the genetic language shared by every living organism. Piece by piece, the universe is allowing us to read its own autobiography. Perhaps the most comforting aspect of this story is its gentleness. Life was not forced into existence. It was invited slowly by conditions that became increasingly favorable over immense stretches of time. Stars created the elements. Gravity assembled the planets. Water shaped the chemistry. Energy sustained countless experiments. Time patiently allowed complexity to accumulate. Every chapter quietly prepared the next. As we search for life elsewhere among the stars, this perspective changes the question we ask. Instead of wondering whether life is a miraculous exception, we begin asking whether the same patient story has unfolded on other worlds. Somewhere beneath an icy moon, around a distant red dwarf, inside an ocean hidden beneath frozen crusts, or upon a rocky planet circling another quiet star. Perhaps the universe has been telling this long story many times, and perhaps, even now, somewhere beyond the reach of our current instruments, another world is slowly making its own quiet journey from simple chemistry toward living complexity, following the same ancient path that began billions of years ago and eventually allowed the cosmos to awaken and wonder about itself through eyes like ours. 6. When stars became cosmic factories. If the universe had stopped after creating hydrogen and helium, no mountains would ever have risen beneath an open sky. No oceans would have reflected the stars. No trees would have stretched toward the sunlight. And no living creature would ever have taken its first breath. The early universe possessed astonishing simplicity. It was vast beyond imagination, yet chemically poor. Almost everything consisted of the lightest elements born during the first few minutes after the Big Bang. Hydrogen filled the expanding cosmos like an endless, invisible sea, while helium quietly accompanied it in enormous abundance. Together, they were enough to build the first generation of stars, but they were not enough to build worlds like our own. Something else had to happen first. The universe needed factories, not factories built from steel or stone, humming with machinery beneath towering roofs, but factories powered by gravity itself. These were places where temperatures climbed into millions of degrees, where pressure reached unimaginable extremes, and where atoms were slowly transformed into entirely new forms of matter. Those factories were stars. Every star is, in a sense, a great workshop hidden inside the darkness of space. From a distance, a star appears peaceful. It shines steadily night after night, almost unchanged across a human lifetime. Yet beneath that calm surface lies extraordinary activity. Deep within its core, atomic nuclei collide at incredible speeds, overcoming the natural forces that normally keep them apart. Hydrogen atoms fuse together. Their tiny masses combine, releasing tremendous amounts of energy. That energy travels outward over thousands or even hundreds of thousands of years before finally escaping into space as light. The sunshine warming your face today began its journey long before human civilization existed. Stars are patient in everything they do, but light is only one of their gifts. As hydrogen slowly becomes exhausted inside a star's core, gravity begins compressing the interior even further. Temperatures rise higher, new nuclear reactions become possible. Helium begins fusing into carbon. Carbon later helps create oxygen. Larger stars continue this remarkable sequence, forging neon, magnesium, silicon, sulfur, calcium, and eventually iron. Each stage requires even greater heat and pressure than the last. It is almost as though every star spends its lifetime learning increasingly difficult forms of cosmic craftsmanship. Imagine an artist who begins with only a single color. Over time, they discover another, then another. Eventually, an entire palette becomes available, allowing paintings of astonishing richness. The universe experienced something similar. Before stars existed, chemistry possessed only the simplest colors. After countless generations of stellar evolution, nature acquired an entire spectrum of elements from which worlds could be painted. Carbon became the foundation of organic chemistry. Oxygen made water possible. Silicon formed rocks and mountains. Iron settled into planetary cores, helping generate magnetic fields that protect atmospheres from harmful radiation. Calcium would someday strengthen bones. Phosphorus would help carry genetic information. Every new element expanded the possibilities available to the cosmos. Yet, even stars have limits. Iron presents one of the most fascinating turning points in astrophysics. Unlike lighter elements, fusing iron consumes energy instead of releasing it. Once a massive star builds an iron core large enough, its internal balance begins to fail. For millions of years, gravity and nuclear fusion exist in perfect partnership. Gravity constantly pulls inward. Fusion constantly pushes outward. Their quiet competition keeps the star stable. But when fusion can no longer support the immense weight pressing inward, gravity suddenly gains the upper hand. The collapse happens with astonishing speed. The core contracts in seconds. Temperatures soar. Shock waves race outward. And then the star explodes. A supernova is among the most spectacular events the universe can produce. For a brief time, one dying star may shine brighter than billions of ordinary stars combined. Entire galaxies can momentarily appear dim beside its brilliance. Yet, despite the violence, destruction is only part of the story. During those final explosive moments, temperatures and pressures become so extreme that entirely new elements are forged. Gold, silver, uranium, platinum, iodine, and many others too heavy to form during ordinary stellar fusion. Nature performs some of its finest craftsmanship at the very moment a star dies. Then comes perhaps the most beautiful chapter of all. The explosion scatters these newly created elements across enormous distances. What once belonged to a single star becomes part of the wider galaxy. Clouds of enriched gas drift quietly through interstellar space for millions of years. Eventually, gravity gathers them once more into fresh stellar nurseries. New stars ignite, new planetary systems emerge, new worlds begin forming from the recycled remains of ancient suns. Nothing is wasted. The universe is remarkably economical. Every ending quietly prepares another beginning. When astronomers say that we are made of stardust, they are not speaking poetically. They are describing literal history. The iron carrying oxygen through your bloodstream was almost certainly forged inside a massive star that lived and died billions of years before our sun was born. The calcium inside your teeth, the phosphorus within every strand of your DNA, the oxygen filling your lungs, the carbon forming every cell in your body. Each atom has traveled an unimaginably long journey through cosmic history. Long before becoming part of you, those atoms drifted through interstellar clouds, glowed inside stellar furnaces, survived violent explosions, and wandered the galaxy before finally gathering into the cloud that formed our solar system around 4.6 billion years ago. There is something deeply comforting about that thought. Our bodies are not separate from the universe. They are among its latest creations. Every person becomes a temporary arrangement of matter that has already experienced countless previous forms. One day those atoms will continue traveling again, joining new cycles beyond our own lives. The universe never truly stops building. Even now, throughout distant galaxies, newborn stars are beginning their quiet work. Some are only millions of years old, barely beginning to fuse hydrogen. Others are approaching the final chapters of their existence. Still others have already exploded, scattering fresh supplies of heavy elements into surrounding space where future planets may someday form. Across billions of light years, these immense factories continue operating without pause, generation after generation, century after century, billion year after billion year. They ask for no recognition. They announce no completion. They simply continue the patient labor that has shaped every solid world, every ocean, every atmosphere, and every living organism we have ever known. Perhaps that is why looking up at the stars feels strangely personal. We are not merely observing distant objects suspended in the night sky. We are looking toward ancient ancestors. Long before Earth existed, long before life emerged from quiet chemistry, and long before human beings ever wondered about their place in the cosmos, countless forgotten stars were already preparing the materials that would one day become mountains, forests, birdsong, oceans, and curious minds capable of gazing back toward the heavens. The universe did not simply create us. It patiently forged us, one atom at a time, inside the silent factories of stars whose names we will never know, yet whose ancient light and extraordinary labor continue to live on within every heartbeat, every breath, and every quiet moment beneath the endless night sky. 7. How the universe learned to observe itself. The universe spent billions of years creating stars. It spent billions more creating planets. On at least one of those planets, it patiently guided chemistry toward life, life toward complexity, and complexity toward intelligence. And then, after almost 14 billion years of silent evolution, something extraordinary happened. The universe opened its eyes. Of course, this is not meant literally. The cosmos does not possess eyes, thoughts, or intentions in the way human beings do. Yet there is something undeniably profound about the fact that, through conscious life, the universe has become capable of reflecting upon itself. For billions of years, stars burned without witnesses, galaxies collided without observers, black holes formed in complete silence, light traveled across unimaginable distances, never falling upon curious minds capable of asking where it came from. Then, on one small rocky planet, orbiting an ordinary yellow star, molecules slowly assembled into cells. Cells became organisms. Organisms evolved nervous systems. Eventually, after countless generations, one species began lifting its gaze toward the night sky. Perhaps consciousness is not separate from the universe at all. Perhaps it is one of the universe's own natural processes. This thought has fascinated scientists, philosophers, and poets alike for centuries. It does not suggest that the universe itself is consciously thinking, nor does it claim that stars possess awareness. Rather, it reminds us that every conscious mind is built entirely from matter that has always belonged to the cosmos. The atoms inside our brains were once scattered through ancient stars. The electrical signals racing between our neurons obey the same physical laws that guide lightning through clouds and charged particles across distant nebulae. Nothing within us exists outside nature. Everything we are emerged from it. That realization changes the way we think about ourselves. It is easy to imagine humanity standing apart from the universe, as though we are visitors examining something foreign. But perhaps that picture is incomplete. A wave is not separate from the ocean. It is simply one expression of the ocean's movement. Likewise, conscious beings may simply be one expression of the universe organizing itself into forms capable of perception. The remarkable journey toward awareness was astonishingly gradual. For most of Earth's history, life remained simple. Single-celled organisms dominated the planet for billions of years. They adapted, reproduced, and evolved, yet none left behind telescopes or mathematics. None painted images of galaxies or wondered about the age of the cosmos. Then evolution began exploring increasingly complex nervous systems. Creatures developed eyes, others developed ears. Some learned to navigate by smell, by sound, or by Earth's magnetic field. Each new sense expanded the amount of information life could gather from its surroundings. Eventually, brains became capable not only of reacting to the world, but of constructing internal models of it. Memory appeared, learning accelerated, curiosity emerged. Some animals recognized themselves in mirrors. Others solved intricate problems or communicated through surprisingly sophisticated signals. Then, relatively recently on the cosmic timeline, human beings began asking questions that reached far beyond immediate survival. Why do the stars move? What are they made of? Where did everything begin? These questions marked an extraordinary turning point. For the first time, the universe contained creatures attempting to understand the very processes that had created them. Modern neuroscience tells us that consciousness arises through astonishingly complex interactions among billions of neurons. No single neuron contains awareness by itself. Yet together, they produce experiences, memories, imagination, and reflection. This idea offers an intriguing parallel to many other systems in nature. A single water molecule is not a wave. A single ant is not a colony. A single star is not a galaxy. Sometimes entirely new properties emerge when countless simple parts begin interacting together. Scientists call this emergence. Consciousness may be one of nature's most remarkable examples, not because it violates physical law, but because it demonstrates how extraordinary complexity can arise from remarkably simple foundations. We still do not fully understand how subjective experience emerges from physical processes. This remains one of the deepest mysteries in science. Researchers continue exploring countless ideas, from neural networks and information theory to integrated models of brain activity. Despite enormous progress, no single explanation has yet answered every question. In many ways, consciousness remains as mysterious as the universe itself. Perhaps that is fitting. The instrument attempting to solve the mystery is also part of the mystery. Every telescope humanity has ever built ultimately depends upon human perception. Every scientific equation is interpreted by conscious minds. Every discovery becomes meaningful because someone experiences it. Without observers, knowledge cannot truly exist in the form we understand it. Yet observation itself also changes our relationship with reality. When ancient people looked upward, they saw points of light decorating the heavens. Today, we recognize those same points as immense nuclear furnaces, some larger than our entire solar system. The sky itself has not changed. Our understanding has. In a sense, every scientific discovery expands not only human knowledge, but also the universe's capacity to know itself through us. This perspective is both humbling and comforting. It reminds us that curiosity is not something separate from nature. Curiosity is one of nature's own creations. The desire to ask questions emerged through the same evolutionary processes that shaped wings, forests, oceans, and galaxies. Perhaps wondering is as natural as gravity. Perhaps imagination is another quiet consequence of billions of years of cosmic evolution. When a child asks why the moon changes shape, when an astronomer studies distant galaxies, or when someone simply pauses beneath a clear night sky and feels a sense of awe, the universe is, in a very real sense, examining its own history. Not because the cosmos possesses intentions, but because the matter composing curious minds has inherited the ability to reflect. Carl Sagan once expressed a similar thought when he described humanity as a way for the cosmos to know itself. Whether viewed poetically or scientifically, the idea continues to resonate because it captures something deeply true about our origin. We are not spectators standing outside reality. We are participants within it. Every heartbeat follows physical laws billions of years old. Every memory depends upon atoms forged inside ancient stars. Every thought arises from matter that has traveled across cosmic history before briefly arranging itself into a mind capable of asking questions. Perhaps that is why the night sky feels so profoundly moving. When we look toward the stars, we often imagine ourselves observing something distant. Yet, those stars are also observing us in another sense. Not through awareness of their own, but through the extraordinary chain of events they helped begin long ago. Without their light, their chemistry, and their patient labor as cosmic factories, there would be no eyes to see, no minds to wonder, and no stories to tell. The universe spent billions of years preparing this quiet conversation with itself. And tonight, beneath the same ancient sky that watched galaxies grow and stars ignite, every thoughtful question, every peaceful moment of reflection, and every quiet sense of wonder becomes another gentle chapter in that endless dialogue. If these calm reflections help you unwind after a long day, don't forget to subscribe so we can continue exploring the quiet mysteries of existence together. 8. The accidents that changed everything. Some of the greatest chapters in the universe's history may never have been inevitable. We often imagine the cosmos unfolding according to perfect laws, as though every galaxy, every star, every planet, and every living creature were destined to appear exactly as they have. Yet modern science paints a far more subtle picture. While the laws of physics remain astonishingly reliable, the events unfolding within those laws often depend upon chance, timing, and countless tiny circumstances. The universe follows rules, but its story is not entirely predictable. Perhaps nowhere is this more beautifully illustrated than in the remarkable sequence of unlikely events that eventually made our own existence possible. Imagine watching billions of tiny dominoes standing across an endless landscape. The rules governing how each domino falls never change. Yet whether one particular domino strikes another depends on its exact position, the slightest movement of air, or a tiny difference in timing almost too small to notice. History unfolds through both law and circumstance. The universe appears to work much the same way. The first stars, for example, did not all form simultaneously. Some regions of space contained slightly more matter than others, allowing gravity to gather gas a little faster. Those first differences were incredibly small, almost invisible against the smooth background of the young universe. Yet, without those tiny fluctuations, gravity might never have gained enough advantage to build galaxies at all. Everything we know may ultimately trace back to differences smaller than one part in 100,000. Such an astonishing idea reminds us that immense consequences sometimes emerge from almost imperceptible beginnings. As galaxies matured, another series of unlikely events quietly unfolded. Not every star was massive enough to create heavy elements. Many smaller stars lived calm, stable lives for billions of years, producing light, but contributing relatively little to the rich chemistry required for rocky planets. Only certain massive stars ended their lives as spectacular supernovae. Only those explosions scattered enormous quantities of carbon, oxygen, silicon, iron, and countless other elements across interstellar space. Had fewer massive stars formed during the universe's youth, the chemistry available to later generations of planets might have been profoundly different. The ingredients of life were never guaranteed. They were patiently assembled through countless stellar lifetimes. Even the birth of our own solar system carries signs of extraordinary coincidence. Astronomers believe our sun formed inside a vast cloud already enriched by much older stars. Somewhere nearby, one or perhaps several supernova explosions likely compressed portions of that cloud, helping trigger the collapse that eventually created our sun. Those same explosions also supplied radioactive elements that warmed the interiors of young planets during their earliest history. Ancient stellar deaths may therefore have influenced not only the material from which Earth formed, but also its internal evolution. One generation of stars quietly prepared the next. The timing had to be remarkably fortunate. Too early, and the galaxy contained too few heavy elements. Too late, and entirely different conditions might have existed. Earth itself inherited another remarkable collection of fortunate circumstances. Our planet formed within a region where temperatures allowed liquid water to remain stable for billions of years. It possessed enough gravity to retain a substantial atmosphere, yet not so much that crushing pressures transformed its surface into something resembling Venus. A magnetic field generated deep inside its molten core helped shield the atmosphere from the relentless stream of charged particles flowing outward from the sun. Plate tectonics slowly recycled carbon between Earth's surface and interior, helping regulate the planet's climate across immense stretches of time. None of these individual features alone created life. Together, they produced extraordinary stability. Perhaps the most dramatic accident in Earth's later history arrived about 66 million years ago. A large asteroid, roughly 10 kilometers across, struck what is now the Yucatan Peninsula. The impact released more energy than billions of nuclear bombs. Enormous wildfires swept across continents. Dust filled the atmosphere. Global temperatures changed dramatically. Many forms of life disappeared forever. At first glance, the event appears to be nothing more than catastrophe. Yet its consequences reshaped the future of life. The extinction of the non-avian dinosaurs opened ecological opportunities that mammals gradually filled over millions of years. Eventually, one branch of those mammals developed increasingly sophisticated brains, capable of language, culture, science, and reflection. Had that asteroid missed Earth entirely, intelligent life might still have emerged someday. Or perhaps it would not. No one can say with certainty. History often turns upon moments that become visible only in retrospect. Evolution itself depends upon countless such moments. Every mutation begins as a tiny change within genetic instructions. Most accomplish very little. Some disappear almost immediately. A few prove beneficial under particular circumstances, spreading gradually through future generations. Nature does not plan these changes. It explores them. Across millions of years, innumerable small variations accumulate into astonishing diversity. The wings of birds, the eyes of octopuses, the echolocation of bats, the enormous brains of whales, the hands capable of building telescopes. Each emerged through long sequences of small events, none of which could have predicted the remarkable future they helped create. Chance and necessity dance together throughout the history of life. The laws of biology shape what is possible. Random variation explores those possibilities. Selection quietly preserves what proves successful. The universe seems surprisingly comfortable allowing creativity to emerge from uncertainty. Modern physics offers similar lessons. On the smallest scales, quantum events introduce probabilities rather than absolute certainty. Individual outcomes cannot always be predicted with complete precision, although the larger statistical behavior remains astonishingly reliable. Nature appears to embrace both order and unpredictability simultaneously. The great cosmic story therefore resembles neither rigid destiny nor complete randomness. Instead, it unfolds like a magnificent improvisation performed within timeless physical laws. Every chapter remains connected to those laws, yet the precise details continue surprising us. Perhaps that is why the universe feels endlessly fascinating. It follows elegant principles without becoming repetitive. It creates familiar patterns without repeating identical histories. No two stars live exactly the same life. No two planets develop identical surfaces. No two living organisms share precisely the same journey. Even identical twins gradually become different through countless experiences accumulated across time. Variation seems woven into reality itself. There is something deeply comforting hidden within this understanding. Our existence does not become less meaningful because it depended upon unlikely events. If anything, it becomes more precious. The atoms composing your body survived ancient stellar explosions. Earth endured billions of years of changing climates. Life passed through mass extinctions, volcanic upheavals, shifting continents, and countless evolutionary experiments before eventually producing minds capable of reading the history written across the night sky. Every generation inherited a universe shaped by innumerable moments that could easily have unfolded differently. And yet, here we are, able to wonder, able to remember, able to ask questions about events that occurred billions of years before anyone existed to witness them. Perhaps the greatest miracle is not that every accident produced perfection. It is that the universe possesses such extraordinary resilience. Again and again, uncertainty becomes opportunity. Loss becomes renewal. Small changes ripple outward across immense stretches of space and time, eventually giving rise to galaxies, forests, oceans, civilizations, and quiet conversations beneath the stars. Looking upward tonight, it is humbling to realize that the cosmos was never a perfectly scripted story. It has always been a patient dialogue between timeless laws and countless unexpected moments. And somewhere within that delicate balance of certainty and chance, the universe slowly created beings capable of wondering whether their own existence was one of its most beautiful accidents of all. 9. The hidden balance. Behind reality. The universe often appears effortless. The sun rises each morning with remarkable consistency. Planets continue tracing graceful paths around their stars. Galaxies rotate through the darkness, and the laws of physics seem so dependable that we rarely stop to question why everything remains so stable. But beneath this quiet appearance lies one of the greatest wonders in all of science. Reality is not held together by certainty alone. It survives because countless invisible balances are maintained every moment across the entire cosmos. These balances are so precise, so deeply woven into the fabric of existence that we almost never notice them. Only when we imagine what would happen if even one of them failed, do we begin to appreciate how extraordinary our universe truly is. Consider something as simple as our own planet. At this very moment, Earth is falling toward the sun. That statement sounds alarming, but it is completely true. Gravity constantly pulls Earth inward. If gravity were the only force at work, our planet would spiral directly into the sun. Yet, that never happens. Why? Because Earth is also moving sideways through space at nearly 30 kilometers every second. Its forward motion perfectly complements the sun's inward pull. Instead of crashing into the sun or escaping into deep space, Earth continually falls around it. Our orbit is not the absence of falling. It is falling with perfect balance. Every sunrise is possible because of this quiet partnership between motion and gravity. The moon performs a similar dance around Earth. Satellites circle our planet, using the very same principle. Galaxies themselves remain together through delicate relationships between gravity, momentum, and the distribution of both visible and invisible matter. The universe seems remarkably skilled at balancing opposing tendencies. Gravity gathers matter together. Expansion pushes galaxies farther apart. Stars collapse inward under their own weight. Nuclear fusion pushes outward from their blazing cores. Atoms attract one another to build molecules. Heat encourages them to move apart. Everywhere we look, stability emerges not because only one force exists, but because multiple influences quietly counterbalance one another. Imagine an enormous orchestra performing without a conductor visible on stage. Violins, cellos, flutes, percussion, and brass each follow different musical lines. Individually, they sound incomplete. Together, they produce harmony. If even one section drifts too far from the others, the entire performance changes. The universe resembles such an orchestra. Countless physical processes occur simultaneously, each influencing the others in subtle ways. Harmony emerges because no single process dominates forever. Perhaps nowhere is this balance more astonishing than inside every star. Gravity spends every moment attempting to compress a star into an ever smaller sphere. The immense weight of its outer layers presses relentlessly toward the center. Yet deep within the core, nuclear fusion releases tremendous energy. That energy creates outward pressure, powerful enough to resist gravity's constant pull. For millions or even billions of years, these opposing influences remain almost perfectly matched. Stars shine because neither side wins? Only when nuclear fuel becomes exhausted does the balance finally shift. Gravity gradually gains control. The star changes, sometimes gently, sometimes spectacularly. Even the existence of atoms depends upon extraordinary equilibrium. Electrons do not simply collapse into atomic nuclei, nor do they drift endlessly away. Quantum mechanics establishes stable arrangements where particles occupy specific energy levels. Without these delicate rules, chemistry itself would become impossible. No molecules, no water, no rocks, no DNA, no life. Reality as we know it depends upon balances operating far below anything human eyes can observe. These invisible relationships extend across even greater scales. The expansion of the universe offers another remarkable example. Since the Big Bang, space itself has been stretching. Galaxies gradually drift farther apart as the cosmos grows larger. For much of cosmic history, gravity slowed this expansion. Every galaxy pulled upon every other galaxy, gently resisting the outward motion inherited from the universe's birth. Then, billions of years later, astronomers discovered something unexpected. Expansion was accelerating. Some unknown influence, what we now call dark energy, appears to be gently overcoming gravity across the largest scales imaginable. The exact nature of dark energy remains mysterious. Yet, whatever it may be, it participates in the ongoing balance shaping cosmic evolution. The universe is still adjusting, still evolving, still maintaining relationships whose full nature we have not yet completely understood. Even the fundamental constants of physics appear astonishingly precise. The strength of gravity, the electromagnetic force, the strong nuclear force holding atomic nuclei together, the weak nuclear force governing certain radioactive processes. Each possesses values that allow stable matter to exist. If these constants differed significantly, stars might never ignite, carbon might never form, atoms themselves might become unstable. Scientists continue debating whether these values are inevitable, accidental, or part of deeper principles we have yet to discover. Whatever the answer, their remarkable harmony allows an extraordinarily rich universe to exist. There is beauty in realizing that stability does not require rigidity. Nature achieves endurance through dynamic balance. Think about riding a bicycle. A bicycle standing still often falls. Yet once moving, countless tiny adjustments keep it upright. Balance becomes an active process rather than a fixed position. The universe behaves similarly. Stars pulse, galaxies rotate, planets orbit, magnetic fields shift, atmospheres circulate. Nothing remains completely motionless. Stability emerges through continuous change. Perhaps this idea also appears within life itself. Every human body constantly replaces cells. Atoms enter and leave through breathing, eating, and countless chemical reactions. Your body today contains many atoms that were not part of you several years ago. Yet your identity feels continuous. Life preserves order not by preventing change, but by carefully managing it. The universe repeatedly demonstrates that permanence is often an illusion. Balance, not stillness, creates endurance. This perspective changes how we understand apparent certainty. The night sky appears calm because enormous balances quietly succeed every second. Stars continue shining because gravity and fusion remain in conversation. Galaxies endure because countless gravitational interactions maintain their overall structure. Earth remains habitable because oceans, atmosphere, geology, sunlight, and countless chemical cycles continue supporting one another. Every peaceful evening beneath the stars depends upon invisible partnerships extending across scales from subatomic particles to clusters of galaxies. Perhaps that is one of the universe's most profound lessons. The strongest systems are rarely those dominated by a single force. Instead, they arise when many influences coexist in careful proportion. Order survives because opposing tendencies continuously shape one another. Creation and destruction, expansion and attraction, motion and stability, energy and structure. Each requires the others. Without gravity, stars could never ignite. Without outward pressure, stars would collapse immediately. Without entropy encouraging change, nothing new would ever emerge. Without organizing forces resisting complete disorder, complexity could never endure. Reality itself exists within this remarkable conversation. As our understanding deepens, we discover that the universe is less like a rigid machine and more like a magnificent symphony of relationships, where every particle, every star, every galaxy, and every living mind participates in an endless dance of balance. Perhaps that is why the cosmos feels both powerful and peaceful at the same time. Its greatest strength does not come from absolute certainty. It comes from countless invisible balances, quietly maintained across billions of years, allowing light to continue shining, worlds to continue turning, and conscious beings to continue wandering beneath a sky that has never stopped holding itself together with extraordinary grace. 10. Why complexity keeps growing. At first glance, the universe seems as though it should become simpler with time. After all, we know that stars eventually exhaust their fuel. Mountains slowly erode beneath wind and rain. Buildings decay. Living organisms grow old. Even the second law of thermodynamics tells us that, over long periods, disorder or entropy tends to increase. If everything naturally drifts toward greater disorder, then why does the history of the universe appear to tell the opposite story? Why did a nearly uniform sea of hydrogen and helium gradually become galaxies? Why did galaxies produce stars? Why did stars create planets? Why did chemistry become biology? Why did biology eventually give rise to consciousness capable of wondering about its own origins? Against all expectations, complexity has continued to emerge. This is one of the quiet paradoxes that makes the universe so endlessly fascinating. The key to understanding this mystery lies in recognizing that increasing disorder does not prevent islands of remarkable order from forming. In fact, under the right conditions, the two often grow together. Imagine placing a pot of water over a gentle flame. As heat enters the water, the individual molecules begin moving more energetically. At first glance, everything seems increasingly chaotic. Yet after a short time, something unexpected happens. Beautiful convection currents appear. Warm water rises. Cooler water sinks. Graceful circular patterns begin flowing through the pot. More energy has entered the system, yet organized motion has emerged rather than disappeared. Nature often behaves this way. Energy flowing through matter can produce extraordinary structure. Our own planet offers another beautiful example. Earth constantly receives energy from the sun. That sunlight does not simply warm the surface. It drives winds across continents. It powers ocean currents. It fuels weather systems. It allows plants to capture light through photosynthesis. Those plants become food for animals. Entire ecosystems emerge because energy continues flowing through them. Without the constant arrival of sunlight, Earth would gradually cool toward lifeless simplicity. Complexity survives because fresh energy continually enters the system. The universe follows the same principle on grander scales. Stars are engines of energy. For billions of years, they pour enormous amounts of light into surrounding space. Planets intercept tiny fractions of that energy. Atmospheres begin circulating. Chemistry becomes increasingly adventurous. Eventually, on worlds possessing the right conditions, life may emerge. Life itself represents one of the most astonishing examples of organized complexity ever discovered. Every living cell contains intricate molecular machinery operating with astonishing precision. Proteins fold into exact shapes. DNA stores vast libraries of information using only 4 chemical letters. Tiny molecular machines transport materials, generate energy, repair damage, and copy genetic instructions with remarkable accuracy. None of this appeared all at once. Each layer of complexity gradually accumulated upon previous layers. Simple chemistry became self-replicating chemistry. Self-replication became evolution. Evolution explored countless possibilities across billions of years. Slowly, organisms became more diverse, more specialized, more interconnected. The universe seems surprisingly patient when building complexity. It rarely leaps forward. Instead, it adds one successful innovation after another. A single-celled organism discovers photosynthesis. Later organisms inherit that achievement. Multicellular life appears. Nervous systems emerge. Eyes evolve independently several times. Brains become larger. Language develops. Knowledge begins passing between generations rather than disappearing with individual lives. Eventually, entirely new forms of complexity arise that no longer depend solely upon biology. Human civilization stores information in books, libraries, computers, satellites, digital networks. Ideas now survive beyond individual lifetimes. Knowledge itself has become part of Earth's evolving complexity. Perhaps complexity grows because successful patterns rarely disappear completely. Instead, they become foundations for future structures. Consider a city. No single person constructs every building. Each generation inherits roads, bridges, schools, and knowledge created by previous generations. New achievements build upon older ones. Civilizations become more intricate because history accumulates rather than continually restarting. Nature behaves similarly. Stars inherit heavy elements produced by earlier stars. Planets inherit enriched chemistry. Life inherits successful genetic innovations. Cultures inherit accumulated knowledge. Complexity grows through memory. The universe remembers, not through conscious thought, but through the persistence of successful structures across time. Even galaxies reveal this layered history. The Milky Way did not appear fully formed. It grew gradually by merging with smaller galaxies, capturing star clusters, and continuously forming new generations of stars. Every spiral arm preserves traces of countless earlier events. Every planetary system carries chemical signatures inherited from long-forgotten stellar ancestors. The present always contains echoes of the past. Perhaps that is one reason complexity keeps increasing. Nothing begins from nothing anymore. Every new creation starts with richer materials than what existed before. The first stars possessed only hydrogen and helium. Our sun inherited dozens of heavier elements. Earth inherited all of them. Life inherited Earth's chemistry. Human civilization inherited life. Science inherited civilization. Each generation begins farther along the journey. Yet, there remains an important balance. Although local complexity grows, the universe as a whole still obeys the second law of thermodynamics. Stars radiate energy into space. Heat gradually spreads. Entropy increases overall. Local order is purchased by exporting even greater disorder elsewhere. A living organism remains highly organized only because it continuously exchanges energy with its surroundings. The same applies to planets, stars, and galaxies. Complexity does not violate thermodynamics, it flourishes within it. This realization transforms what once appeared to be a contradiction into something deeply elegant. The universe has not escaped its own laws. It has discovered astonishing possibilities within them. Simple physical principles have generated remarkable richness without ever abandoning their original simplicity. Perhaps this teaches us something profound about creativity itself. Great complexity does not necessarily require complicated rules. Sometimes, a few elegant principles repeated over immense stretches of time become sufficient to create extraordinary diversity. A handful of fundamental forces, a modest collection of elementary particles, several physical constants. Given billions of years, these simple ingredients produce galaxies, oceans, butterflies, symphonies, mathematics, literature, telescopes, and conversations like this one. The universe appears almost infinitely inventive, despite beginning so with remarkably little. Perhaps that is its greatest surprise? When we gaze at a forest, it is easy to admire its complexity without noticing the simple genetic instructions shared by every tree. When we observe a galaxy, we marvel at billions of stars without remembering that gravity follows the same equation everywhere. When we look at ourselves, we often forget that every thought arises from atoms obeying laws billions of years older than humanity itself. Complexity can sometimes hide simplicity rather than replace it. As science advances, this pattern appears again and again. The deeper we look, the more we discover that astonishing richness often emerges from surprisingly elegant foundations. Perhaps that is why the universe feels simultaneously mysterious and understandable. It never abandons its basic rules. Instead, it explores every beautiful possibility those rules quietly allow. Tonight, as countless stars continue shining across the darkness, the great story of complexity is still unfolding. New stars are forming within distant nebulae. New planets are assembling around young suns. New chemical experiments are taking place beneath frozen oceans and inside warm atmospheres scattered across the galaxy. Somewhere, perhaps, another world is taking its first small steps toward life. Elsewhere, life may already be wondering about the same questions we ask beneath our own night sky. The universe has spent nearly 14 billion years demonstrating one extraordinary truth. From astonishing simplicity, given enough energy, enough patience, and enough time, beauty has an almost remarkable tendency to become more intricate, more connected, and more aware. And perhaps the greatest complexity it has ever created is not any single galaxy or civilization, but the endless ability of the cosmos to keep discovering new ways of becoming more than it was before. 11. The unexpected power of fragility. Some of the strongest influences in the universe do not announce themselves with spectacular explosions or dazzling displays of power. Instead, they exist as fragile arrangements, delicate balances that endure not because they are indestructible, but because they have quietly learned how to survive within an ever-changing cosmos. At first, this idea seems almost contradictory. When we imagine the forces that shape galaxies, we think of gravity-crushing stars into black holes. We picture supernovae brighter than entire galaxies, or colossal collisions between clusters of galaxies spanning millions of light years. Power appears dramatic. Fragility appears temporary. Yet, the deeper we study the universe, the more often we discover that its longest-lasting achievements depend not upon overwhelming strength, but upon extraordinary delicacy. Consider the atom. Everything around you, every mountain, every ocean, every leaf, every breath, every heartbeat, is built from unimaginably tiny structures whose stability depends upon an almost perfect balance. Inside each atom, positively charged protons occupy an incredibly small nucleus. Electrons exist as quantum probability clouds surrounding that nucleus. The forces binding these particles together operate with astonishing precision. If the strong nuclear force were only slightly weaker, many atomic nuclei would never remain intact. If electromagnetism behaved differently, chemistry itself would change beyond recognition. Atoms seem permanent during human lifetimes, yet their stability depends upon relationships so subtle that they challenge our intuition. Matter itself is a masterpiece of quiet balance. That same elegance extends into chemistry. A single water molecule appears wonderfully simple. 2 hydrogen atoms joined to 1 oxygen atom. Yet because of its unusual shape and electrical properties, water behaves unlike almost any other liquid. Ice floats instead of sinking. Water stores enormous amounts of heat. It dissolves an astonishing variety of substances. These seemingly modest characteristics transformed the history of Earth. Had ice been heavier than liquid water, lakes and oceans would freeze from the bottom upward, dramatically altering the possibility of life surviving long winters. Instead, floating ice forms insulating layers that protect the liquid water beneath. One fragile molecular property quietly preserved entire ecosystems across billions of years. Nature often hides immense consequences inside delicate details. Now consider DNA. Within nearly every living cell lies a molecule so thin that millions of strands could fit across the width of a fingernail. It appears almost impossibly fragile. Radiation can damage it. Chemicals can alter it. Heat can separate its intertwined strands. Yet this remarkably delicate molecule has carried life's instructions continuously for nearly 4 billion years. Generation after generation, species after species. Without ever intending to, every living organism becomes a temporary guardian of information stretching back toward Earth's earliest oceans. DNA survives not because it never changes. It survives because it balances stability with flexibility. It copies itself accurately enough to preserve life's achievements. Yet occasional small variations allow evolution to continue exploring new possibilities. Too much change would destroy inherited information. Too little change would prevent adaptation. Life depends upon another extraordinary balance. Fragility becomes the source of resilience. The same lesson appears on much larger scales. Our own atmosphere is astonishingly thin. If Earth were reduced to the size of a classroom globe, the breathable portion of our atmosphere would be thinner than a coat of fresh paint. From space, this delicate blue layer appears almost insignificant. Yet within it unfold nearly every event that matters to life on Earth. Clouds form, rain falls, birds migrate, seeds travel upon the wind. Oxygen circulates, temperatures remain suitable for liquid water. This fragile veil protects us from harmful radiation, while allowing sunlight to nourish forests, oceans, and countless living creatures. Without it, Earth would become almost unrecognizable. Sometimes the smallest shields protect the greatest treasures. Even stars themselves demonstrate the surprising power of delicate equilibrium. Throughout most of a star's life, gravity constantly attempts to compress it inward. Fusion pushes outward with equal persistence. The slightest long-term imbalance eventually transforms the star completely. Yet many stars maintain this remarkable equilibrium for billions of years. Our sun has remained sufficiently stable to allow life on Earth to evolve from simple microbes into complex civilizations. Such stability is not guaranteed. It is earned every second through an ongoing conversation between opposing forces. Perhaps one of the most beautiful examples of cosmic fragility lies within planetary orbits. The Earth does not travel along invisible rails. Its orbit exists because gravity and motion continuously cooperate. The solar system itself resembles an intricate dance rather than a rigid machine. Every planet gently influences every other planet through gravity. Over immense stretches of time, these interactions subtly reshape orbital paths. Yet remarkably, the overall system remains stable. Small adjustments accumulate without leading to complete chaos. The dance continues. Astronomers observe similar elegance throughout galaxies. Spiral arms are not permanent structures carved into space like grooves on a record. Instead, they resemble enormous traffic patterns created by billions of stars moving together under gravity. Individual stars drift into and out of these spiral regions over hundreds of millions of years. The pattern survives even though its individual participants constantly change. The structure endures precisely because it remains flexible. It is another reminder that lasting beauty often depends upon movement rather than rigidity. This principle extends beyond astronomy into nearly every level of nature. Forests survive storms because trees bend. Coral reefs recover because countless small organisms rebuild them. Ecosystems remain healthy because diversity allows adaptation. Even human bones, though seemingly solid, constantly rebuild themselves throughout life. Strength is rarely absolute. It is usually dynamic. Science repeatedly reveals that systems capable of gentle adjustment often outlast those that resist every change. Perhaps this helps explain one of evolution's greatest achievements. Life never became successful by creating perfect organisms. Instead, it produced organisms capable of responding to imperfect circumstances. Every heartbeat adjusts to changing activity. Every immune system adapts to unfamiliar microbes. Every brain continuously rewires itself through learning. Survival belongs not to flawless designs, but to flexible ones. Fragility, when balanced with adaptability, becomes a remarkable source of endurance. The universe seems to understand this lesson instinctively. Stars evolve, galaxies merge, continents drift, species appear and disappear. Nothing remains exactly the same forever. Yet, through continuous adjustment, the larger story continues unfolding. Perhaps permanence was never the goal. Perhaps continuity was. There is something deeply comforting hidden within this realization. We often admire only the largest and strongest features of the cosmos: the blazing stars, the immense galaxies, the powerful black holes. Yet much of existence depends upon things that appear almost unimaginably delicate. Thin atmospheres, tiny molecules, invisible magnetic fields, gentle chemical bonds, subtle gravitational balances, quantum probabilities. Invisible threads of interaction quietly support every visible wonder. Without them, the grandest structures would quickly disappear. Looking up at the night sky, it becomes tempting to believe that the universe is built entirely from overwhelming power. But perhaps its greatest achievements tell another story. Perhaps the galaxies shining across the darkness owe just as much to patience as to force, just as much to fragile equilibrium as to overwhelming energy, just as much to quiet persistence as to dramatic transformation. The history of the cosmos reminds us again and again that delicacy should never be mistaken for weakness. Some of the most fragile structures ever created have endured across billions of years, carrying information, preserving balance, nurturing life, and quietly shaping everything that followed. And perhaps that is one of the universe's most profound lessons. The things that appear most easily broken are often the very things that make everything else possible. They ask for no attention. They create no spectacle. They simply continue their silent work, holding together worlds, stars, and living minds with a grace so subtle that we notice it only when we pause long enough to wonder how such delicate beauty has survived for so very long. 12. When intelligence joined the cosmic story. Before there were questions, there were only answers. The laws of physics governed every interaction with perfect consistency. Gravity gathered matter into stars. Stars forged the elements. Planets assembled from ancient clouds of dust. Oceans formed beneath young skies. And life slowly emerged through billions of years of patient evolution. The universe was already magnificent, but it remained silent. Not because sound did not exist, but because no mind yet existed to ask what any of it meant. For almost the entire history of the cosmos, there was no curiosity, no wonder, no astonishment beneath a clear night sky. Galaxies spun through darkness without witnesses. Supernovae briefly outshone entire galaxies, yet no eyes looked upward to admire their brilliance. Black holes bent space and time without inspiring stories, mathematics, or imagination. The universe simply continued being itself. Then, on one small planet orbiting an ordinary star, in an unremarkable spiral arm of the Milky Way, something extraordinary happened. Matter learned to ask questions. This moment was not marked by fireworks or dramatic cosmic events. No distant galaxy suddenly changed course. No new physical law appeared. Instead, it unfolded quietly through the gradual evolution of countless generations. Simple nervous systems became more sophisticated. Memory became richer. Communication became increasingly complex. Eventually, language emerged. And with language came an entirely new ability. The ability to share ideas across generations. Unlike instinct, which is inherited biologically, knowledge could now be accumulated, refined, corrected, and expanded through culture. A child no longer needed to rediscover everything from the beginning. Each generation could begin where the previous one had ended. This simple shift transformed the pace of understanding. Imagine climbing an enormous mountain. If every traveler were forced to begin again from the valley, progress would be painfully slow. But if each traveler starts from the point reached by those before them, the summit gradually comes within reach. Human knowledge has grown in much the same way. Each discovery becomes a foundation for future discoveries. Each question leads naturally toward another. The universe had created a species capable not only of surviving, but of remembering. Perhaps this is one of intelligence's greatest powers. It stores experience, not only within individual brains, but within civilizations themselves. The invention of writing changed everything. Thoughts could outlive thinkers. Observations made thousands of years ago could still guide modern scientists. Questions once whispered around ancient fires eventually became the foundation of astronomy, mathematics, chemistry, and physics. Ideas acquired remarkable longevity. They began traveling through time almost as effectively as light travels through space. As civilizations advanced, humanity's picture of the universe changed dramatically. For countless generations, people believed Earth stood motionless at the center of everything. The stars appeared fixed upon a celestial sphere. The heavens seemed perfect and unchanging. Then observation quietly challenged certainty. Careful measurements revealed subtle inconsistencies. New instruments extended human vision. The telescope transformed tiny points of light into astonishing new worlds. Mountains appeared on the moon. moons circled Jupiter, Venus displayed phases. The sky itself became evidence. One by one, assumptions gave way to deeper understanding. This process continues today. Science is not remarkable because it always provides immediate answers. It is remarkable because it continually invites better questions. Every solution uncovers another mystery waiting just beyond it. When astronomers discovered that our galaxy was only one among hundreds of billions, humanity's place in the universe became simultaneously smaller and more extraordinary. When physicists uncovered quantum mechanics, reality itself became stranger than anyone had imagined. When biologists decoded DNA, life revealed itself as an intricate language written with astonishing elegance. Knowledge does not shrink mystery. It often enlarges it. Every horizon reached reveals another beyond. Perhaps that is why intelligence fits so naturally into the cosmic story. The universe has always evolved through increasing complexity. Stars built heavier elements. Planets developed richer chemistry. Life explored biological diversity. Conscious minds introduced reflection. Science introduced cumulative understanding. Each chapter expanded what became possible. Intelligence did not interrupt cosmic evolution, it continued it. There is something profoundly moving about realizing that every scientific instrument humanity has ever built represents an extension of our natural senses. Telescopes allow our eyes to see farther. Microscopes reveal worlds too small for ordinary vision. Radio antennas hear frequencies beyond human ears. Particle accelerators recreate conditions from the earliest moments of cosmic history. Spacecraft carry our curiosity across the solar system. Each invention expands the reach of awareness. Little by little, the universe observes itself with greater clarity. Yet, perhaps intelligence is measured not only by the answers it discovers, but by the humility it develops. The more science learns, the more carefully it distinguishes certainty from possibility. We now understand that dark matter outweighs ordinary matter, yet we still do not know exactly what dark matter is. We recognize that dark energy influences the expansion of the universe, yet its true nature remains mysterious. We understand that consciousness arises within the brain, yet the full relationship between physical processes and subjective experience remains one of science's greatest unanswered questions. Knowledge teaches confidence. Wisdom teaches patience. The two grow together. Perhaps that is one of the most beautiful characteristics of intelligent life. It does not merely collect facts. It develops perspective. The night sky viewed by an astronomer is physically identical to the night sky viewed by a child, yet each sees something different. One recognizes stellar evolution, planetary dynamics, and galactic structure. The other experiences pure wonder. Both perspectives possess immense value. Science deepens wonder rather than replacing it. Understanding does not diminish beauty, it enriches it. Knowing that the light from a distant galaxy traveled for billions of years before reaching your eyes makes the experience even more astonishing. Knowing that the atoms within your body were forged inside ancient stars transforms ordinary existence into something quietly extraordinary. Perhaps intelligence reaches its highest expression not when it claims mastery over the universe, but when it recognizes its intimate connection to it. Every neuron depends upon atoms created by stars. Every thought follows physical laws billions of years older than humanity. Every question emerges from matter that has journeyed across cosmic history before briefly becoming capable of reflection. We are not visitors examining the universe from outside. We are one of its newest chapters, one of its most intricate conversations, one of its quietest miracles. Somewhere tonight, countless people will step outside beneath dark skies. Some will simply admire the stars. Others will search for familiar constellations. A few may pause long enough to wonder where everything began. Without realizing it, each of them continues a tradition older than recorded history itself. The questions have changed. The instruments have improved. The answers have grown more detailed. Yet the sense of wonder remains remarkably constant. It is the same curiosity that first inspired ancient observers to lift their eyes toward the heavens. It is the same curiosity driving modern spacecraft toward distant planets. And perhaps it will someday guide future civilizations far beyond anything we can presently imagine. For billions of years, the universe evolved without asking a single question. Then, through life, through intelligence, and through countless generations of patient curiosity, it became capable of wondering about its own existence. That quiet transformation may be among the greatest milestones in cosmic history, not because it changed the laws of nature, but because it allowed those laws to be understood, appreciated, and shared. If these gentle stories bring a little peace before sleep, subscribe and let every new episode become another quiet step through the history of the cosmos. 13. The endless climb toward understanding. Before every great discovery came a quiet moment of uncertainty. Someone looked at the night sky and admitted, "I do not understand." That simple sentence has changed the course of human history more than perhaps any other. It is tempting to imagine knowledge as a destination, a distant summit waiting to be reached after enough questions have been answered. Yet the history of science tells a different story. Understanding is not a finish line, it is a mountain range. Every peak we climb reveals another horizon stretching beyond it. Every answer opens the door to deeper mysteries that could not even have been imagined before. Perhaps this endless climb is not a flaw in human knowledge. Perhaps it is its greatest strength. The earliest observers of the heavens believed they could almost understand the entire universe simply by watching the stars move across the sky. To them, the cosmos appeared relatively small. The sun rose, the moon changed its phases, constellations returned with reliable seasons. The heavens seemed orderly, elegant, and complete. There was mystery, certainly, but it felt manageable. Then the telescope arrived. Suddenly, the moon revealed mountains and valleys instead of a perfectly smooth surface. Jupiter possessed moons of its own. Saturn displayed mysterious rings. The Milky Way dissolved into countless individual stars. The universe had quietly grown larger overnight. Yet what truly expanded was not the cosmos itself. It was humanity's awareness of how much remained unseen. Every generation has experienced a similar awakening. When Isaac Newton described gravity with extraordinary mathematical precision, many believed that nature's deepest secrets had finally been uncovered. His equations explained falling apples, planetary orbits, tides, and the motion of comets with astonishing accuracy. For more than 2 centuries, they seemed almost complete. Then came Albert Einstein. Space and time, once considered separate and absolute, became intertwined into a single fabric capable of bending beneath mass and energy. Gravity was no longer simply a force acting across empty space. It became geometry itself. Newton had not been wrong. He had simply described one layer of a far deeper reality. The climb continued. Quantum mechanics soon challenged intuition in entirely different ways. Particles behaved like waves. Waves behaved like particles. Observation itself became intertwined with probability. The universe refused to conform to everyday expectations. Again, understanding expanded. Again, mystery expanded with it. Today, physicists possess remarkably successful theories, describing both the largest structures in existence and the smallest known particles. Yet, these theories remain incomplete. General relativity beautifully explains gravity across galaxies. Quantum mechanics astonishingly predicts microscopic behavior, but the two frameworks refuse to merge completely. Somewhere beyond our current understanding lies a deeper description that has yet to reveal itself. The climb continues. Astronomy tells a similar story. For centuries, the Milky Way seemed to contain everything. Then Edwin Hubble demonstrated that distant spiral nebulae were actually entirely separate galaxies. Suddenly, our cosmic neighborhood expanded from one galaxy to hundreds of billions. Later observations revealed that ordinary matter, the stars, planets, gas, and dust we can directly observe, accounts for only a small fraction of the universe's total contents. Dark matter outweighs visible matter. Dark energy dominates the universe's large-scale evolution. Together, these invisible components appear to compose about 95% of the cosmos. In other words, after centuries of remarkable progress, humanity discovered that most of reality remains fundamentally mysterious. Far from discouraging scientists, this realization inspires them. The unknown has always been science's greatest invitation. Perhaps the most beautiful feature of knowledge is that it grows by replacing certainty with better questions. Ancient people asked why the stars moved. Today, astronomers ask how galaxies formed, whether life exists elsewhere, and what happened during the first fractions of a second after the Big Bang. Tomorrow's questions may be entirely different, not because today's questions are unimportant, but because every discovery transforms the landscape of curiosity itself. Questions evolve. That evolution may be one of intelligence's greatest achievements. Imagine exploring an enormous library whose shelves extend beyond sight. Each book you read helps you understand the next. Yet every completed volume also reveals references to countless others you have not yet opened. Rather than making the library feel smaller, reading continually reveals how immense it truly is. The universe resembles such a library. Each discovery illuminates another corridor. Each explanation uncovers another shelf, waiting patiently in the darkness. Perhaps this is why science remains endlessly exciting despite its careful methods. Contrary to popular belief, scientific progress is rarely driven by people convinced they already possess the answers. Instead, it flourishes through curiosity disciplined by evidence. The greatest researchers often spend years investigating questions whose solutions remain uncertain. Many experiments fail. Many hypotheses prove incomplete. Many ideas must be abandoned. Yet every unsuccessful attempt refines the search. Even mistakes become valuable. Nature rewards patience. The history of astronomy illustrates this beautifully. For decades, astronomers searched for planets orbiting distant stars. Many believed such worlds almost certainly existed, yet no direct evidence appeared. Then, in the 1990s, the first confirmed exoplanets were discovered. Today, thousands are known. Some orbit two stars, some possess scorching atmospheres hotter than molten lava. Others drift freely through interstellar space without orbiting any star at all. Entire categories of worlds previously absent from human imagination suddenly became part of scientific reality. Every discovery expanded possibility. Perhaps somewhere among those distant planets, another civilization has begun climbing its own mountain of understanding. Perhaps beneath another sky, curious minds ask questions strikingly similar to ours. Or perhaps they ask questions we cannot yet imagine because their experiences, environments, and histories differ entirely from our own. The universe almost certainly contains possibilities beyond the boundaries of human intuition. Recognizing those limits is itself a form of wisdom. Even mathematics, often considered the purest language of certainty, reveals endless frontiers. Every solved theorem inspires new conjectures. Every elegant proof uncovers deeper structures. Infinity itself possesses layers more astonishing than most people realize. Knowledge expands not because reality becomes more complicated, but because our ability to recognize its hidden patterns continues growing. Perhaps that is why humility remains one of science's quiet virtues. The more humanity learns, the less convincing absolute certainty becomes. Every generation once believed it stood near the end of discovery. Every generation later realized it had only reached another beginning. This pattern is unlikely to end. There will always be another telescope capable of seeing farther, another particle detector capable of probing deeper, another mathematical insight connecting ideas previously thought unrelated, another child asking a question no one has considered before. The universe appears remarkably generous in providing new mysteries. It never seems to run out. Looking upward tonight, it is extraordinary to remember how far humanity has already climbed. Our ancestors once navigated using the stars without knowing what stars truly were. Today, we measure the ages of galaxies, detect planets orbiting distant suns, observe black holes, study gravitational waves, and reconstruct events that occurred nearly 14 billion years ago. Each achievement would have seemed almost magical to previous generations. Yet even now, we stand only partway up the mountain. Beyond today's horizon lie questions whose very existence we have not yet discovered. Perhaps that is the most inspiring truth of all. The universe is not becoming smaller as we understand it. It is becoming deeper. Every answer reveals another layer of elegance hidden beneath the last. Every discovery invites another journey. And every step upward reminds us that the endless climb toward understanding may itself be one of the greatest adventures the cosmos has ever made possible. 14. Could complexity ever end? For nearly 14 billion years, the universe has displayed an extraordinary tendency. Again and again, from remarkable simplicity, it has given rise to greater richness. Clouds of hydrogen became stars. Stars forged heavier elements. Those elements assembled into planets. On at least one small world, chemistry became biology. Biology became intelligence. Intelligence began asking questions about the very universe that had produced it. Each chapter appears more intricate than the one before. It is almost tempting to believe that complexity is an unstoppable force, destined to increase forever. But the universe asks a quieter question. What if complexity has limits? Could there come a time when the cosmos simply runs out of new possibilities? Will there be a final masterpiece after which nothing more complicated can ever emerge? Or does creation itself possess an endless capacity for surprise? These questions lead us toward one of the deepest mysteries in modern cosmology. The answer depends not only on what complexity is, but on what kind of future the universe ultimately chooses. At first glance, the future seems promising. Stars continue to form inside enormous clouds of gas. Young planetary systems still appear throughout the Milky Way. Galaxies continue merging, creating fresh opportunities for new generations of stars. The universe has certainly not stopped building. Yet astronomers also know that this creative era cannot last forever. Stars require hydrogen. Although the universe contains an astonishing amount of it, hydrogen is not infinite. Every second, countless stars quietly convert enormous quantities of hydrogen into helium. Little by little, the available fuel decreases. Over unimaginably long timescales, fewer new stars will appear. Galaxies will slowly grow darker. The brilliant age we currently inhabit is only one chapter within a much longer cosmic story. Imagine walking through a vast forest in early autumn. Most trees remain covered with leaves. Birds still fill the air. Streams continue flowing. Nothing suggests immediate change. Yet somewhere within every leaf, invisible chemical processes have already begun preparing for winter. The transformation is gradual, almost imperceptible. The universe may now occupy a similar season. It still possesses extraordinary creative energy, but its greatest era of star formation already lies behind it. Observations suggest that galaxies today produce new stars far more slowly than they did billions of years ago. The cosmos remains fertile. It is simply becoming less prolific. Does this mean complexity must eventually decline? not necessarily, because complexity does not depend only upon creating new stars. It also depends upon what existing structures continue doing with the resources they already possess. Consider Earth. Our planet formed roughly 4.5 billion years ago. Life emerged relatively early, yet biological complexity continued increasing for billions of years afterward. The sun did not need to become brighter every century for evolution to continue exploring new possibilities. Instead, existing energy supported increasingly sophisticated forms of organization. Simple organisms gradually became ecosystems. Ecosystems gave rise to intelligence. Complexity often grows by rearranging existing ingredients rather than requiring entirely new ones. Human civilization illustrates this beautifully. Modern cities are not built from fundamentally new atoms. They contain iron, carbon, silicon, oxygen, and countless familiar elements. What has changed is organization. Knowledge accumulates. Technology improves. Ideas combine in novel ways. Complexity expands through relationships rather than raw material alone. Perhaps the universe behaves similarly. Even if star formation gradually slows, existing civilizations, should they exist elsewhere, might continue generating entirely new forms of culture, science, art, and technology for billions of years. The physical ingredients remain the same. The patterns become richer. Some scientists even wonder whether intelligence itself may become one of the universe's most important creators of future complexity. Stars build atoms. Life builds meaning. Conscious minds transform physical matter into libraries, observatories, spacecraft, music, mathematics, and philosophy. Information becomes another layer of cosmic evolution. In this sense, complexity may increasingly depend upon thought rather than merely upon chemistry. Yet another possibility appears even more fascinating. The universe may still contain environments where entirely unfamiliar forms of organization are waiting to emerge. We naturally assume that complexity resembles life as we know it, but nature has repeatedly surprised us before. Deep beneath Earth's oceans, ecosystems flourish without sunlight. Extremophils survive inside boiling springs, frozen deserts, and highly acidic lakes. Life continually demonstrates astonishing adaptability. Elsewhere in the universe, entirely different pathways toward complexity may already exist. Perhaps beneath frozen oceans surrounding distant moons. Perhaps inside atmospheres of giant planets. Perhaps in environments we have not yet imagined. Our imagination should never become the boundary of reality. Still, every discussion of complexity eventually encounters thermodynamics. The second law reminds us that entropy continues increasing. Energy gradually becomes more evenly distributed. Useful energy becomes harder to concentrate. Eventually, stars exhaust their fuel. Black holes evaporate over inconceivably long timescales. The universe approaches increasing simplicity. At least, that is the traditional picture. Yet even here, fascinating uncertainties remain. Some theoretical physicists have proposed that quantum processes occurring across unimaginable stretches of time could generate entirely new events. Others explore models in which our universe forms only one chapter within a far larger cosmic landscape. Some suggest that new universes might emerge through processes associated with black holes or quantum fluctuations. These ideas remain speculative. Evidence remains incomplete, but they remind us that the final chapters of cosmic history have not yet been written. Perhaps the greatest lesson science has taught us is that endings are often more complicated than they first appear. History repeatedly demonstrates this pattern. The death of massive stars creates the heavy elements needed for planets. Mass extinctions open opportunities for entirely new forms of life. Galactic collisions stimulate fresh waves of star formation. What appears to be an ending frequently becomes a beginning viewed from another perspective. Nature rarely wastes transitions. Perhaps complexity itself follows similar cycles. It may decline in one form only to reappear in another. Patterns dissolve, new patterns emerge, information reorganizes. The universe continuously explores fresh arrangements of familiar ingredients. Even within our own lives, this rhythm feels strangely familiar. Children become adults. Civilizations rise and transform. Languages evolve. Ideas migrate between cultures. Nothing remains unchanged forever, yet meaning persists through continual renewal rather than permanent stability. Perhaps permanence was never complexity's goal. Transformation may have been its true nature all along. Looking upward tonight, the stars appear timeless. Yet every one of them participates in a story of change. Some are only beginning their long lives. Others quietly approach old age. Some have already disappeared, their ancient light still crossing space toward Earth. The sky itself is constantly evolving, although the changes unfold far too slowly for human eyes to notice. The same may be true of complexity. We often imagine it as a destination. Perhaps it is better understood as an ongoing process, a conversation rather than a conclusion, an unfolding rather than an achievement. As long as energy flows, relationships form, information accumulates, and curious minds continue asking new questions, complexity retains the possibility of surprising itself once again. Whether the universe eventually reaches perfect simplicity or discovers entirely unforeseen pathways toward greater richness remains one of the deepest unanswered questions in science. No observation has yet revealed the final chapter. No equation has fully described the ultimate future. And perhaps that uncertainty is fitting. For a universe that has spent billions of years transforming simplicity into galaxies, stars, oceans, life, and consciousness, has earned the right to keep one final mystery quietly waiting beyond the horizon. Perhaps complexity will one day end, or perhaps somewhere far beyond anything we can presently imagine, the cosmos is already preparing its next astonishing beginning, hidden within processes so subtle that today they remain invisible to every telescope, every equation, and every curious mind beneath the stars. 15. The quiet future of everything. For as long as human beings have looked toward the stars, we have quietly imagined ourselves as part of the universe's story. Every civilization has left traces of this desire. Ancient monuments aligned with the rising sun. Stone circles followed the changing seasons. Sailors navigated oceans by the constellations. Astronomers mapped planets. Physicists uncovered invisible laws. Each generation added another sentence to a conversation that had begun long before anyone remembered its first words. Yet an unsettling question eventually appears. What happens when there is no one left to continue asking? If every civilization eventually fades, if every voice grows silent, if every telescope ceases scanning the heavens, does the universe's story also end? Or does it continue unfolding with the same quiet patience it always has? Perhaps the answer reveals something profoundly beautiful. The universe has never depended upon observers in order to exist. For billions of years before life appeared, galaxies formed without applause. Stars ignited without witnesses. Entire clusters of galaxies slowly assembled while no eyes existed anywhere to admire their astonishing scale. The cosmos has always been capable of writing magnificent chapters in complete silence. Long after every known civilization disappears, that silent creativity may continue. Imagine an ancient forest standing deep within an isolated valley. No roads reach it. No maps record its location. No human being has ever walked beneath its towering trees. Birds continue singing at dawn. Rain nourishes the soil. Seeds drift gently upon the wind. New saplings quietly replace ancient giants that finally fall. The forest remains alive regardless of whether anyone observes it. Its beauty does not depend upon an audience. The universe may possess the same quiet independence. Stars will continue evolving according to physical laws that require neither recognition nor admiration. A young star born within a distant nebula millions of years from now will not know whether intelligent life exists anywhere nearby. Gravity will continue gathering gas. Fusion will ignite. Planets may slowly assemble from surrounding dust. The story unfolds because the universe continues being itself. Perhaps there is something deeply comforting in that realization. Humanity often measures significance through attention. We celebrate achievements because someone remembers them. We preserve history because we fear forgetting. Nature, however, seems unconcerned with recognition. A flower blooms whether or not anyone notices. Snow falls across remote mountains that no traveler will ever climb. Lightning illuminates distant clouds above empty oceans. Beauty often exists simply because existence itself allows it. The cosmos appears wonderfully generous in this way. It creates without demanding applause. Looking toward the far future, astronomers expect profound transformations. Star formation will gradually decline as galaxies consume their remaining reservoirs of hydrogen. The brilliant spiral arms we admire today may slowly fade. Many galaxies will merge into larger systems. The night skies of distant epochs will look very different from our own. Yet even then, remarkable events will continue. White dwarf stars may slowly cool for trillions of years. Neutron stars will quietly orbit one another until gravity eventually brings them together. Black holes will continue influencing their surroundings with silent patience. Entire planetary systems may wander through intergalactic darkness long after their parent galaxies have changed beyond recognition. The pace of cosmic history will slow. It will not necessarily stop. There is a tendency to imagine the future as increasingly empty, but emptiness itself can contain astonishing stories. Between galaxies stretches enormous darkness. Yet even those immense regions contain wandering particles, invisible radiation, magnetic fields, and subtle gravitational influences extending across unimaginable distances. What appears empty often proves quietly active. Perhaps the future universe will resemble a vast library after sunset. The readers have gone home. The lights are dim. Silence fills every room, yet the books remain. Every page still carries knowledge waiting patiently. The stories have not vanished. Only their audience has changed. Likewise, stars, planets, and galaxies carry histories written into their very existence. Every atom remembers ancient stellar furnaces through its composition. Every planetary crater records forgotten impacts. Every orbit preserves traces of countless gravitational encounters stretching backward through time. The universe archives itself continuously. Even without conscious observers, those records endure. Some physicists speculate that information itself may never completely disappear. Although the exact nature of this principle remains one of modern physics' great mysteries, it suggests something remarkable. Events may leave subtle traces that persist long after their visible consequences have faded. Reality possesses memory of a kind, not memory through thought, memory through structure. Every present moment inherits the consequences of every previous one. If that is true, then every civilization that ever exists contributes permanently to the unfolding history of the cosmos. Even if cities vanish, even if languages disappear, even if stars eventually consume the planets that once nurtured intelligent life, the universe itself continues carrying the consequences forward. Nothing meaningful is entirely isolated. Everything becomes part of what follows. This perspective changes how we imagine endings. Throughout nature, endings rarely erase what came before. When stars die, they enrich galaxies with heavier elements. When forests burn, new ecosystems eventually emerge from fertile soil. When rivers change course, entirely different landscapes begin forming. The visible chapter concludes. Its influence continues. Perhaps civilizations follow the same pattern. Knowledge may spread beyond its birthplace. Technology may reshape planetary environments. Signals may travel outward through space long after their creators are gone. Even simple radio transmissions already form expanding spheres, moving quietly into the Milky Way at the speed of light. Long after Earth itself has changed beyond recognition, those faint whispers will continue crossing interstellar darkness. Somewhere, unimaginably far in the future, they may still exist. Perhaps no one will ever receive them, yet they will continue traveling nonetheless. The universe rarely hurries. Its greatest stories unfold across timescales that dwarf human imagination. A mountain feels ancient to us. A galaxy views mountains as brief geological moments. Stars measure time differently. Black holes measure it differently still. The future contains stretches of time so vast that language struggles to describe them meaningfully. And across those immense ages, quiet transformations may continue unfolding without interruption. Perhaps entirely new forms of order will emerge. Perhaps unfamiliar kinds of matter will organize themselves in ways we cannot presently imagine. Perhaps quantum fluctuations, gravitational interactions, or processes not yet understood will continue surprising the cosmos long after familiar stars have faded. Science remains honest enough to admit that many of these possibilities remain uncertain. The future has not revealed all of its intentions, yet uncertainty itself has always been one of the universe's greatest invitations. Every generation inherits mysteries untouched by those before it. Every horizon conceals another. Perhaps that pattern extends all the way to the end of time, if time itself possesses an end. Standing beneath today's night sky, it becomes surprisingly easy to feel small. The universe is vast beyond comprehension. Our civilization occupies only a brief moment within its history. Our entire recorded past lasts less than the blink of an eye compared with cosmic time. Yet, perhaps significance has never depended upon duration. A single star enriches future galaxies. A single seed becomes an ancient forest. A single question transforms an entire civilization. Meaning often arises not from lasting forever, but from becoming part of something that does. The universe may continue writing stories long after every known observer has vanished. New stars may shine. Ancient remnants may slowly change. Invisible forces may continue shaping worlds that no conscious mind will ever discover. Silence will return, just as it existed before life first appeared. But it will not be an empty silence. It will be the quiet continuation of a story that has never required an audience in order to remain beautiful. And perhaps that is one of the gentlest truths the cosmos offers us. Long after every voice has faded, every monument has crumbled, and every civilization has become part of history, the universe will almost certainly continue doing what it has always done best. Patiently, gracefully, and without ever asking to be seen, it will keep becoming itself. 16. The story. That complexity continues to tell. For thousands of years, humanity believed that the universe was a collection of objects. There were stars, there were planets, there were comets crossing the heavens, there were mountains, oceans, and living creatures upon a small blue world. Reality appeared to consist of things, but as science slowly deepened our understanding, an extraordinary realization began to emerge. The universe is not merely a collection of things. It is a collection of relationships. Every galaxy exists because gravity gathers billions of stars into graceful spirals and luminous clusters. Every star shines because gravity and nuclear fusion maintain a delicate conversation lasting millions or billions of years. Every living cell survives because countless molecules cooperate with astonishing precision. Even every thought passing quietly through your mind depends upon billions of neurons exchanging tiny electrical signals and patterns of breathtaking complexity. The story of the cosmos has never simply been about matter. It has always been about connection. Perhaps that is why complexity continues unfolding. Not because the universe endlessly creates new ingredients, but because familiar ingredients discover endlessly new ways of belonging together. Consider the alphabet. Only 26 letters compose the English language. Yet from those few symbols emerge novels, poems, scientific discoveries, songs, histories, and conversations capable of moving hearts across centuries. The letters rarely change. The possibilities seem almost infinite. Nature appears to possess a similar creativity. The periodic table contains a little more than 100 naturally occurring elements. From those modest ingredients arise snowflakes, coral reefs, towering forests, hummingbirds, galaxies, symphonies, computers, telescopes, and civilizations capable of contemplating the birth of the universe itself. The ingredients remain surprisingly simple. The relationships become endlessly richer. Perhaps this explains why the cosmos never appears repetitive. Stars may follow familiar physical laws, yet no two planetary systems develop in exactly the same way. Every galaxy carries its own history. Every world experiences its own sequence of events. Every living species explores a unique evolutionary journey. The universe seems to delight in variation, not through randomness alone, but through countless opportunities for familiar laws to produce unfamiliar outcomes. This continual unfolding resembles the growth of an ancient tree. The trunk remains connected to every branch. Each branch supports countless smaller branches. Leaves emerge, they fall, new ones appear. The tree never abandons its original structure. Instead, it quietly expands through time. The universe has grown much the same way. Elementary particles formed atoms. Atoms formed stars. Stars formed planets. Planets nurtured chemistry. Chemistry became biology. Biology produced consciousness. Consciousness created culture. Culture generated science. Science now allows the universe to understand chapters of its own history that once existed only in silence. Each layer depends upon everything beneath it. Nothing stands alone. Perhaps the greatest surprise is that this unfolding process has not slowed. Even today, somewhere within distant nebulae, new stars continue igniting. Around young suns, fresh planetary systems gradually assemble from swirling disks of gas and dust. On Earth, evolution continues adapting life to changing environments. Human knowledge expands through every observation, every experiment, every thoughtful conversation. The story remains unfinished. There is something wonderfully humble about recognizing this. Our generation often feels surrounded by extraordinary technology. We have mapped the human genome. We have landed spacecraft on distant worlds. We have photographed the shadow of a black hole. We have detected tiny ripples in space-time caused by merging black holes billions of light years away. These achievements are remarkable, yet they almost certainly represent only the opening chapters of a much longer story. Future generations may understand dark matter. They may uncover entirely new laws of physics. They may discover life beyond Earth. They may ask questions that have not yet occurred to us because the necessary discoveries have not yet been made. Knowledge continues branching like a living tree. The horizon quietly moves forward with every step we take. Perhaps that is the deepest lesson hidden throughout cosmic history. Completion has never been the universe's goal. Transformation has. Every era prepares the next. The first stars created the elements needed for rocky planets. Rocky planets created environments where chemistry could become increasingly sophisticated. Life transformed planetary surfaces. Intelligence transformed information. Each chapter became the foundation upon which another could begin. Even endings participate in this rhythm. stars conclude their lives by enriching galaxies. Dead stars become the material for future generations of stars and planets. Ancient forests nourish young forests. Extinct species leave ecological opportunities for new ones. Nothing meaningful disappears without contributing something to what follows. The universe seems remarkably generous with continuity. Perhaps complexity itself behaves like a river. No single drop of water remains forever. Yet the river continues flowing. Its shape changes. Its path slowly shifts. It nourishes landscapes generation after generation. Likewise, civilizations may rise and fall. Stars may ignite and eventually fade. Galaxies may merge. Black holes may slowly evaporate across unimaginable stretches of time. Yet, the larger story continues. Patterns transform without ending. Relationships reorganize without disappearing completely. Even our own lives quietly participate in this unfolding. The atoms within your body once belonged to ancient stars. Tomorrow they will belong to something else. The ideas you share influence other minds. Those minds create new ideas. Every act of curiosity becomes part of a chain extending beyond any individual lifetime. We often imagine ourselves as small participants within an enormous universe. Perhaps there is another way to see it. Every conscious observer becomes one place where the universe reflects upon itself. Every question asked beneath the night sky continues a conversation billions of years in the making. Every moment of wonder becomes another sentence within the longest story ever told. And remarkably, that story possesses no visible final chapter. Science has revealed many possible futures. Stars will gradually disappear. Galaxies will change. The cosmos will continue evolving across incomprehensible expanses of time. Yet nowhere have we discovered evidence that creativity itself must suddenly cease. Perhaps complexity will someday take forms beyond anything we currently recognize. Perhaps entirely unfamiliar kinds of organization will emerge under conditions unlike those surrounding Earth. Perhaps future intelligences, wherever they arise, will understand the universe in ways that make today's greatest discoveries appear only as first steps. History encourages such humility. Again and again, humanity has mistaken temporary horizons for ultimate boundaries. Again and again, those horizons have quietly expanded. The night sky our ancestors admired remains the same sky above us. Yet, the universe we now understand is infinitely richer than the one they imagined. Who can say how much richer it may become for those who follow? As this peaceful journey through cosmic history draws gently toward its close, perhaps the greatest gift the universe offers is not certainty, but invitation. It invites curiosity instead of finality. It rewards patience rather than haste. It reminds us that beauty often reveals itself gradually, one discovery at a time. The cosmos has spent nearly 14 billion years transforming simplicity into astonishing complexity. From particles to galaxies, from galaxies to stars, from stars to worlds, from worlds to life, from life to minds capable of asking why any of it exists at all. And perhaps tomorrow, another chapter quietly begins, not because the universe has reached its destination, but because it may never have been traveling toward one. Perhaps the journey itself has always been the masterpiece. Thank you for spending this peaceful journey through the hidden story of the cosmos with us. If these quiet reflections help you relax, wonder, or drift gently toward sleep, don't forget to subscribe. Until our next voyage, rest well, and may the universe continue revealing its endless mysteries, one quiet moment at a time.